Hello and welcome to the Computer Vision Power Hour. So, yesterday, my whole system kind of fell on its face. It wasn't a very good power hour. Things were messed up. So I got everything fixed and decided I would come back on today, Friday, which is, different day, but I decided I just had to come back and fix this, right? I had to come back and do an actual Computer Vision Power Hour. Now that everything's fixed, everything's great. We're back in business. I've got OpenCV completely recompiled with CUDA support. Got everything kind of back where it needs to be. So now we can start digging in and playing with some computer vision stuff. I was a little bit frustrated yesterday, but all things happen for a reason, right? It actually forced me to go and hand compile and figure out how to build OpenCV from source with CUDA support for this new video card that I just got recently. And I will have an article up on jeremymorgan.com today describing exactly how I did that, because it was a nightmare to do. It was an absolute nightmare. And everywhere I searched said, do this. CUDA support in Arch Linux is terrible, etc. But it's not that terrible once you figure it out. And I will be releasing that on jeremymorgan.com today. I'll be releasing how I got that going. It has a CMake file. So you can just, if you have a 4080 or a 4090, you can just copy and paste my CMake file, follow the instructions, and build it exactly. If you have a different NVIDIA card, you'll have to do a few changes here and there. But for the most part, you will be able to run CUDA in Arch Linux. And I must say, I rebuilt OpenCV with CUDA support, and it's so much faster. Like, it is definitely faster than just using the GPU, so I'm glad I did it. And we're going to see it today in action. So I'm using the same one, the same file we used last week, right? If you remember last week, we did this. Right now we're looking at a cam in Amsterdam, and we're using this Find Cars classifier that we've used before, and this is terrible. For one, there are no cars in this picture. This is one that's just panning over people. But we're just going to try a few things and try to see if we can modify this image a little bit and do some pre-processing to find cars better. Like I said, there are no cars in this picture, yet we're still finding things for some reason. So this is pretty terrible. This one would be probably better. Oh, there we go. Now we have some cars. Now that the camera is shifted back. And it's okay. I mean, it is spotting one car. I can see it spots fairly well. The rest of it seems to be just kind of making random squares where it thinks there's a car. But anyway, this is a live stream. We might switch between different live streams, kind of depending on what we decide. If you have any questions, feel free to drop them in the chat. Today, I'm going to YouTube and Twitch, but I always stream on Twitch. So Twitch is the place you should follow me if you want to see this kind of fun stuff. So we're going to do a little bit of computer vision fun today. Look at this. This camera kind of goes all over the place. So I've got a few different feeds that I like to use here. I don't remember what this one is. Oh, this one is cars driving by. So this one is not a live feed. This one is just cars driving by, a video that somebody made of cars driving. And this one takes a little bit longer and goes a little bit slower because it downloads the entire file down to the hard drive and then parses it as opposed to a live stream. So we'll probably focus on live streams. But yeah, this one is vehicle detection this is something that was recorded in 2008 or something. As you can see, it runs slower. It was really slow without the GPU support. So I gotta say, I'm pretty happy that the GPU support is there. And jumping into my Restream chat, where I am going to post some stuff, some source code. If you want some source code, I've got some source code. Where are we at here? We have OpenCV face detection demo. I barely even remember that. OpenCV demos, that's what I was looking for. This one has a lot of OpenCV demos from my live streams. So everything we do on the live stream, let's say source code available here. And that will be our, that's the link to the GitHub where I put all kinds of source code up. It's good stuff. And yeah, so this is a video. This one, it looks like it is kind of spotting the cars. It's also spotting a bunch of other random stuff. But let's find a good feed, and then let's start. We'll find a good feed, and then we'll start doing some things. We'll adjust some contrast, stuff like that. We'll just go through and we'll do some blurring. This is one that was really challenging. So this is the one that we worked on last week. This one is super challenging, and I think it's because of the angles of the cars and the amount of noise. Like there's just like a lot of objects around here that our classifier thinks are cars. Like for some reason it thinks this AccuWeather logo is, I don't know. And this is Grand Rapids, Minnesota, I believe. Yeah, Grand Rapids, Minnesota. And it's one of the more challenging ones, so we'll probably start with this one. Now, one thing I want to do here is, you know, as we set this code up, we have this detect vehicles, right? And we pass in a frame into here, and I think I want to return that frame back. That way we can see what we're passing to the classifier, and we can see what the output is, if that makes sense. So we're going to return vehicles and frame, or frame and vehicles. And now we can go here and say vehicles is detect vehicles. We return the frame here, and vehicles equals detect. We're passing in detect vehicles. So we'll say unprocessed vehicles. That way, the frame as it comes in here will return unprocessed. And I'll show you in a minute why that matters. Here we're showing the frame. So we're showing it as its output. Basically, we're taking the video, taking a frame out of it, we're passing it into the car detection. And before we pass it into car detection, we're just taking that exact same frame and displaying it here on video, right? So what we want to do is something very similar, but we want to return the processed one. I don't know why I said unprocessed. That makes no sense. So this one we can say pre-processing. So as we run this, we should have two different windows come up. There we go. Here's vehicle detection and pre-processing. So after we grayscale it, stuff like that, which we're not even grayscaling it yet, we will be able to see what the image looks like that we're passing into the classifier, and we'll see the image that is coming out afterwards. That makes sense. I hope it makes sense. Again, if there are any questions, feel free to ask. So let's start with a grayscale, right? Because this thing is hard to process when we're passing it in colored like that. So in here in detect vehicles, We're taking our classifier path, which is our cars.xml in here. Then we're just passing the frame in directly. We don't want to do that. We want to make it gray. So we'll say, make it gray. And what I'm going to do is create a final image. Here we go. Down here, and I'm going to say final image equals gray. And we're going to pass this final image into the classifier because we're going to do a bunch of stuff. There we go. Final image gray. And that's what we're going to return is final image also. And then the little thing that I set up here will make a little bit more sense. There we go. See, now we have the gray image and we have basically pre-processing. This is what we're passing to the classifier. This is what this is just the unprocessed frame being passed back so that we can see it with our human eyes, and it looks great. As you can see, grayscaling it didn't do much. We're still getting a ton of false positives. We're barely selecting vehicles as they go. So what are some other things we can do to it? Well, we can blur it. So let's blur it. And there we go with our autocorrect or autocomplete. I keep calling it autocorrect. Absolutely is not. So we have an autocomplete here. And just doing a quick tech check to make sure that I am streaming in the places that I think I'm streaming. And it looks like I am. Cool. Coolio. Thank you, everybody, for watching on my stream. Like I said, we're on YouTube again today. I'm going to kind of build up my YouTube channel. I'm going to have some OpenCV stuff on there very soon. So now our final image is going to be blur. We're going to blur it a little bit. So final image will be blur. Now we should see a blurry gray video for our pre-processed image. And hopefully, it doesn't look like it's really doing a better job, does it? But this is what we're passing to the classifier. So maybe we could blur it a little bit more, or maybe we could do some edge detection on it. So let's go over here. JeremyMorgan.com. Tutorials. Let's just grab some of our stuff like dilation. I've got a really good article on dilation here. Now, in order to do that, we got to make this a binary image. So dilation it's probably not going to help us much, but let's try it anyway. So we'll grab our kernel size, which is going to be 5 by 5. We're going to try dilation. And I'm going to change the comments here and say pre-processing and output. So we know where to put everything that's pre-processing in here. So we're going to do some dilation. We'll say kernel size 5.5. That should be fine. Iteration of 1 should be fine. So we're going to dilate. As we go through here, we're passing this in. We're making it gray. Then we're taking blur. We're blurring that gray image. Now we need to take that blur image and pass it into here. And now we'll have dilated image. So our final image will be a dilated image. Let's see if that helps. I don't know, but we'll see. Just a little slower and still getting a lot of false positives, but here's the dilated image. And this should actually help a little bit, I would think. It's kind of dilating it and it's kind of removing some of that noise out of the image. Let's try a different feed really quick with this setup. Let's try this one. This one's a little bit slower, and it'll be even slower with all this pre-processing we're doing now, but, you know, whatever. It'll be just a bit slower. I'm glad I was able to do this, because yesterday I just kind of sat and, like, we were compiling. That compile actually failed after a while, so I didn't want everybody to sit on the stream and wait for the thing to compile. And I'm really glad I didn't, because all you would have seen was a failure. But I got it figured out, as you can see. So this one looks a little bit better. We're getting some false positives up here in the tree. I mean, I don't know. This is what it's seeing. So it definitely should see that white. Yeah, it's seeing that white vehicle pretty well. The one that just did a U-turn there. So, not bad. We will try, I believe this one was Amsterdam, right? Try Amsterdam. We'll see where they're going and see if we can find, yeah, this one's finding windows and stuff. Like, I don't know. Doesn't seem to be working. So we should probably just focus on our most challenging stream, which is this one in Minnesota. This one's the most challenging one, so we'll focus on trying to spot these cars, and maybe we'll grab another live feed. If there's one that's like showing cars straight on coming at us, or maybe to the side, it might be a little bit easier. But this one, you can tell it's having some issues. Let's see, here's what we're seeing here. We could try some edge detection. See if edge detection will work. Once again, I'll go to jeremymorgan.com and we'll grab our edge detection one, which sometimes helps. Grayscaling, blurring. I thought I had edge detection in here. I don't think I do. I could have swore I had edge detection. Here, we can use a canny algorithm to do this. Read edges. Just grab some code. Go to OpenCV. Easy method of edge detection. We will grab, there we go. We have 3 different options from this particular article here. So maybe we don't do dilated image for now. I don't think it helped us a ton. But we're going to try edge detection. We're going to take our blur image and we have several different types of edge detection here that we can try. So what we'll do is just kind of go through, and for our final image, we'll try wide at first. And let's see what wide looks like. We look here, that's pretty good edge detection. That's definitely detecting edges. However, we're not really seeing any cars here. We're not even getting false positives at this point. We're just, a couple false positives. Definitely not picking up vehicles. So let's try a different stream and see if that helps. Instead of our really challenging one, we'll try a less challenging video and see if it picks up Ooh, this one's going slow today. Now, if we look at our pre-processing, our edge detection is probably just a little too aggressive, it looks like. But it is detecting edges. Just looks a little too aggressive, and our cars are not being spotted at all. And that was, the edge detection there was wide. So let's try tight instead. Ideally, we'd like to turn these things into just like giant blocks, which may be the way that we go. And I totally forgot to put on music. Yeah, so this definitely isn't going to work. That edge detection is out of control. So we'll keep our edge detection handy, but probably not going to work too well. Let's try something else. There was another method that I saw a while ago, and they're resizing it and putting it into a NumPy array, which I've done before. It works really well. And if we resize it down, sometimes it works a little bit better. So we're going to try that. We are going to grab some of this code here. We're going to take our frame and resize it and see if that helps. So we got our classifier here. We don't want to change that. For pre-processing, let's resize that thing. So image is going to be frame.resize, 450 by 250. Then we're going to have an image array that we're passing around here. Let's see if that changes things. For us, we're going to resize it down. A lot of computer vision stuff resizes things down to 255 by 255, something like really small sizes. This might mess with our ability to look at the image. Hello, Daniel Shad. Welcome to the stream. First time chatter. What are we doing? We are detecting cars with computer vision, Python, and OpenCV. Cannot resize an array that references or is referenced by another array in this way. So it is not allowing me to resize, but let's try skipping that part of it and just resizing our frame. And see if this works. So yeah, thank you for coming to the stream, Daniel Shad. We are trying to detect cars from live streams with OpenCV. And yeah, the frame resizing is not working. So we'll go back here, put in our frame. We'll make sure that we didn't break anything permanently, and we'll probably come back to that. We'll resize that frame in a different way. So we have grayscale. We've done some blur, some dilation. Basically, we're just trying to make these cars pop out a little bit. And we saw that the dilation was not the way to go, right? So mid, right, tight. or the edge detection was not the way to go. That one didn't help us too much. So we'll go here. This should find the cars and several other things. We want to do some morphology changes here soon. So here's the pre-processed. Here it's coming through. We're picking up some cars, but we're picking up a lot of false positives here. So that's what I want to do is get rid of some of the false positives. Like these little deals over here. I mean, this is pretty close. We could try blurring it some more and maybe that might help. So blur. If we bring this up to like 7, this should blur it more, and we'll see if the blur in this case is helping us. We might go back to the dilated image also and do a little work with dilating. And see? There we go. Now we are more blurry than it was before for our pre-processing, and still picking up the same false positives. So we're picking up some vehicles over here, but it's also picking up all kinds of stuff. We are going to switch feeds again to our most challenging one, which I believe is this one. Our Minnesota one is very challenging because of the angles. And as you can see, we're getting a lot of false positives here. This one is also more blurry. We can try blurring it even more. Let's see if that'll get rid of some of the noise. So we'll do a Gaussian blur 9x9 and see if this works better. Not really. Still a lot of false positives, but look how blurry we are here. Still a lot of false positives. So what can we do? We can dilate them again. We can try dilating them with this extra blur. Let's try the dilation again. Now our final image is going to be dilated image. Yikes. Seems like I got more false positives out of this, which should be giving us fewer. But see, this is part of the fun with computer vision for sure, is you just got to do a lot of adjustments. Now, car detection is something that's been nailed down really well, especially with deep learning systems. But since we're doing it from scratch, trying to figure it out, it's a little rough. I see some dancing squares around here. We're kind of picking up vehicles. What is something else we could do? We could brighten it. Let's see. Contrast and brightness. We could change some of that. Let's see. See if I can steal some code to do that. And our autocomplete might even do it. Adjust contrast. And yeah, this is a little bit different. Let's see. This autocomplete just did the CBT color to gray. Let's see what that looks like. Invalid number of channels in the input image. Gray equals. Oh, okay. We're already doing that. So it's the Equalize histogram. And that's making the cars look more blocky, so they should pop out a little more. But as you can see, we're still getting just tons of false positives off of this. Kind of all over the place. But we can equalize that histogram thing here, and I do want to adjust contrast. So for pre-processing, we're going to say make it gray. Here's another one where it's trying to put it into an image array. Let's try, let's see. I don't think we want to mess with that. Let's try resizing it again. For some reason, it didn't want to do it. So let's see, grab some code here. CV2 resize. I know that I've done this several times before. I don't know why it's working silly today. We could do a CV2 resize of image. And I believe I have a tutorial on that also. Let's check my own tutorials first. Blurring. There it is. Resize an image with OpenCV. And we'll grab our height and width of this. Whoops. And in pre-processing, I want to resize the frame. It's going to be a little bit easier to process. We'll set our output size 400 by 400. Maybe. I mean, I probably should see actually what, let's see what our height and width is that comes in here first on this particular stream. Do this and quit. It is 1080 by 1920. Autocomplete is going wild today. So 1080 by 1920. That is 16 by 9. Let's figure out how to make it way smaller. And we have our scaling factor here. We'll put in for output size, etc. We'll scale it properly. And then we'll have our resized image here, and I'm just copying this code from my blog post that I made a while back on this so that you don't have to sit and watch me type. Oops, what did I do? Inter area is how we're going to do the interpolation. Here's our resized image. And this resized image will be CV2 resize frame. Then we'll take this resized image and drop it in here, and then it will go down that pipeline resized, ideally. And maybe it's just me, but this is definitely going faster for some reason. But here's our resized image. So maybe we resized it a little much, but we're going to take some of that blur off. And yeah, I'm not really sure why now suddenly the feed seems to be going faster. but it does. Let's check that feed. Maybe, I don't even know if this is a real feed, honestly. I just did some searches on YouTube. And yeah, it does seem to be sped up on YouTube also a little bit. So, okay. That's fine. So I'm going to take the blur down now. Now that we've resized it, that blur is pretty aggressive, the Gaussian blur. So let's take this back down to 3 and 3. And our kernel size, we can take that down for the dilated part, also to 3 and 3. So it's a little bit less aggressive. And let's see if this processes things better. Even though now it's going faster. It looks silly. It looks like a bunch of wild people. And we're barely seeing anything. Oh, and I know why. Because we are resizing it. All of our stuff is now screwed up, as far as the mapping. Ah, that is a good point. So all our coordinates are different now that we've resized this. The coordinates are going to be different. So we have to resize this before it goes into the classifier, basically. We're going to take all this before it goes into detect vehicles. I don't know why my right click does not seem to work. We need to resize it before we even pass it into the car detector so that both of them will be resized. And we may not do it right here. We may not stick with this resized thing. We'll just see. Pass in resized image as our frame. Detection, resized image. Now they should match up and they're both going to be smaller. Possibly. Resized image is not defined. It's defined right here. So scaling factor, frame, we have frame shape. CV2 rectangle over resized image. Processed. Vehicles over. I don't know. I broke it. Let's go back here. Try this again. Resized image is not defined. Oh, it's up in here. Okay, so let's see. So before detect vehicles, we needed to resize that stuff. In here, we need frame. So I'm just going to undo a bunch of stuff. There we go. Copy this. We're going to take this one and pass in our frame. Then we'll go down here. We're going to resize our frame before it gets sent in. That way, when it comes back, it should come back smaller. Nope. So for this one, we want to do a resized image. Now it's resized image here and resized image here. Now both of our videos should be the same size, and they are. This makes things a little bit faster. And the video is going a little faster. but resizing it does not seem to help a ton with the false positives and things like that. So let's make it just a little bit bigger. Let's say 800. This is going to cut it down a little bit, and we can see both images on the screen as we're iterating through this code. So that's one of the advantages to resizing it also, is we can see both of them on the screen. It's doing a little bit better with the image detection, but I'm still seeing a ton of false positives. Let's try a different feed and see what it looks like on some of our other feeds that we have. We are up here. Should work better on this one. This one has a lot less noise in it than the other ones, so that's a thing. Of course, this might go even slower now that we're resizing it, but we'll see. This one has some false positives, for sure. But we're detecting this vehicle pretty well. Looks like we're detecting the next one fairly well. So we're getting close. We can pull some of the blurs out and stuff and see what that does. But that's what a lot of computer vision is. It's like this experimentation that we're doing where you're just kind of experimenting with things and seeing where it goes. 3 and 3 is as low as we can go with the blur. We had some canny edge detection going. We could try that again. So instead of the dilated image, we could do canny edge detection wide. And let's see how that affects it. Contrast and brightness. All right, now we're using edge detection, and we're detecting a lot of edges, but we're not detecting any vehicles. So I can find the brightness and contrast code. Preferably one without this contrast. I'm trying to find one without the stupid scroll bar thing. Okay, so that didn't help. Dilated image helped a lot more than the canny stuff. And if we set this to blur for our blurred image, then we should have a whole bunch of false positives. And car detection. I mean, should show a little of both. One thing that we haven't done is done any adjustments to this stuff. Yeah, tons of that. So let's see, count +1. So we may do a little work. I think on next week's stream, I think we might do a little work training a model and working with the model a little bit. Even though this model's worked very well for me in the past. And it could just be the feeds and all the noise in the feeds. But some of the stuff, like it should not be detecting this manhole cover as a vehicle. And whatever it thinks this is over here, I don't know. Now we have a woman walking her dog, and her pant legs are coming up as images. That's what I was looking for. Brightness and contrast control. That's what I was looking for. So if we change the contrast a little bit, that should help too. Even though these look pretty clear. I mean, it looks pretty good, but we're still going to do it a little bit here. I'm going to say brightness and contrast. And we're going to take blur as our input. And now adjusted, we'll go into, we'll use adjusted as our final image and see where it's at right now. Just blast it apart, right? Raise OpenCV exception, bad argument, expected pattern got, okay. So it's probably right here is where, maybe I need to do it before the blur. We'll do brightness and contrast right at the beginning. We'll do frame here and then adjusted. And make it gray. We blur it. I think blur will be our final image for this one. Nope. I am screwing this up somehow. So let's look at it a little closer here. Cap image. Bad argument. Expected pattern got this. 0, 1 through 9 DU. So I'm not sure what pattern it's expecting. Convert scale abs. Let's look this up, and I'm going to see to make sure that I'm using it properly. Scale abs. Alpha, alpha, beta. Adaptive threshold, nope. Okay, so we're removing noise. I need to do, I did this a little bit different. We need to do this after. So I'll kind of explain this after I drop it in. This is going to be our frame. So we'll make it gray, blur it, and then we're going to remove the noise out of this. We will pass this down as our final image. And then we can adjust the contrast after we've done all this. But let us see. So, yeah. Gaussian blur, okay. And that did not work either. Insertion failed. Detect multiscale. It does not like that final image. Interesting. Sobel, we took the blur. Kernel size of 9 is probably too high. Anyway, maybe kernel size of 5. Let's see what error we got here. Scale factor greater than 1. Image depth. Show probably too small. Let's get rid of our scaling here really quick. Processed vehicles. Go back to frame. Since that rescaling it didn't really help this time anyway, so we're going to take that back and see if it will run now. It's going very slow. And then it crashes still. So I thought the resizing was causing that. Turns out, not so much. Blur, run this again. Input array, output array. So maybe I am using the signature wrong here. So for here, we're defining alpha, beta, contrast and brightness, adjusted, frame, adjusted. Now we'll take adjusted, pass that in. It looked like I had the wrong parameters. I was passing in the wrong parameters to convert scale ABS. We'll see if this fixes that problem. Nope. Back. Unbound local area. Local variable adjusted, referenced before assignment. Yeah, that's what I thought I was going to do. Out. Image. I'm going to see what the autocomplete gives me for this particular method. Adjusted equals CV2 convert scale ABS convert scale ABS. It's absolute values, converts the result to 8-bit. On each element of the input array, the function performs 3 operators scaling, taking absolute value. Param, source input array, destination output array, let's just see if this works. That is interesting that that's passed in and it's passed in by reference, which is a little bit weird, but it's probably a good reason for it. DST is not a NumPy array. Okay, so I definitely need to put this stuff into a NumPy array at some point anyway. Could do this from frame. Input and our output are going to be the same thing. See, I don't think this is going to work very well, but we're just about to the end of the hour. So I'm going to have to find some cooler stuff for next week. We'll try some noise reduction stuff next week. Stuff like that. So, looking a little better. It's not great. Not terrible, not great. This is our adjusted image, so we're making it gray. Now I think we can adjust the contrast and things like that. Brightness. Let's just play with the brightness a little bit. Making things really bright or really dark in computer vision as you're pre-processing is a good way to remove noise. So if you've got a lot of little intricate things, sometimes you can kind of blend them out by making things really dark or really light. That's one of the things I'm going to try on our challenging one. That did not change the image much at all. But we've got a few less false positives. Yeah, I expected a lot more out of the brightness control with that one. So our final image is blur. But maybe we'll do a dilated image or something. Try to pass in dilation again, see if that helps. It might. Look at that. Okay, that's definitely brighter, but we're still getting some pretty bad false positives. We're getting a ton of false positives here, along with some actual legit car detection. This feels closer than we've been in the past, though, I will say. A little bit closer now. This car turning around. You can tell this is just a pre-recorded video because we keep seeing the same thing happen over and over in this video as we watch it. But a little better, not horrible. Let's blur it or dilate it. Let's try dilate. So if we follow our path here, we're coming in this frame, turning that into NumPy image so that we can pass it in here. We're converting, using Convert Scale ABS to adjust contrast and brightness. Then that adjusted image is getting passed in here. The gray, we're converting it to grayscale, equalizing the histogram. Then we're passing that into blur. We're blurring it a little bit, which we can blur it a little bit more, I think. And then it's going out to the final image. So if we select dilated image, this will add a dilation layer to it, and we'll see if that makes things better. It might. And we are at the hour mark here today for our Computer Vision Power Hour. Doesn't seem to be much different. However, if you can see over here in our pre-processing view, these cars should be a little easier to detect, I would think, because we're removing noise. Like, we're not picking up that manhole cover anymore because you can't see the manhole cover. But depending on the color of the car, there's our car turning around. It's kind of, kind of cheesy. It's not doing a super job still. Still picking up a lot of false positives. How can we remove some of the noise out of this thing? Well, we can blur it more. Blur it and make it brighter. There's a couple of things we could do. We've already resized it. Let's see what else we could do here. We can mess with the classifier a little bit too. Vehicle cascade. Oh, why does it do that? Detect multiscale. Let's see what kind of options we have for detect multiscale. We've got scale factor, which specifies how much the image size is reduced at each image scale. 1.05, which means a small step for resizing. And yeah, this detect multiscale will resize stuff for us also. How many neighbors each candidate should have? So we have min neighbors. That's 3. Scale factor of 1. Higher numbers, less accuracy. Interesting. So let me look at this one a little bit closer here. In this class reference, classifier, detect multiscale. Kind of trying to see what parameters we can adjust here that might make things. So making this 1 is something that, so we'll scale it to 1 before it does this. And multiscale, scale factor, 1.3. And you can pass these in as a keyword, it says. So we could mess with this a little bit. This is from the OpenCV documentation. Vehicles. Vehicle cascade, which we're doing up here, this cascade classifier. Detect multiscale, this is the one that we know works. So we're going to take this and say vehicles equals vehicle cascade classifier. And we'll do final image. We're importing that as CV2. And this is directly from OpenCV documentation, so it should work. But let's see what happens when we adjust some of these parameters a little bit. If we can get it to work. Feel like it could crash on that first frame, but we'll find out. Nope, it did not. And we are detecting less. However, this also seems to have a lot less false positives. This is the most progress we've made yet as far as detection goes. Because we were having tons of false positives. Now we're getting far fewer. I'm surprised it didn't get that car turning around there too. So one of the things we could do is step back some of the things we did before. So we noticed that this improves the accuracy. So this seems to have improved the accuracy a little bit. But, you know, maybe we're too dilated, we're too blurred, or things like that. So let's take back the dilation and go back to just blur. And this takes a while to start up, but it's totally worth it to see if this helps. We're getting a little bit closer to some better accuracy, I feel, just in adjusting these. So there's the vehicle driving by that it just does not even see at all. So maybe taking dilation back was a bad idea. Now it sees that vehicle because that vehicle is obviously brighter. So it's not seeing the dark vehicles, is what I'm guessing. And instead of this silly slow thing, let's go back to our difficult stream and see what it does there. And it does not find any of them here. Not detecting a single vehicle. There was another one, Amsterdam, that we were looking at earlier. Let's see what it does in Amsterdam. And as you can see, we're kind of moving around. This one is kind of sped up too. Hey, it spotted a vehicle. Definitely spotted a vehicle. There are other vehicles in here, though, that it's not spotting. And this one seems to be running a little fast, too. So I'm probably going to have to figure out how to adjust the frame rate on some of these videos, I think. But we've made a little progress today. Not much, a little bit. I think I'm going to keep adjusting these settings, like minimum neighbors, say 5. Let's go back to this one. Let's see what happens when we change the minimum neighbors to 5. But I'm going to keep adjusting these, I think, and keep those kind of handy. Find cars. This one's taking a while to load. It looks like my bit rate's going all over the place today, so I probably shouldn't be using the video card to encode my output stream and do this computer vision stuff at the same time. So changing the neighbors, that did not help at all. That made it worse. So mid neighbors, 3. And then we'll go back, find cars. What did I do? Undo. Huh. Yeah, it was min neighbors was 3, right? If it seems like this stuff is easy to break, it's because it's easy to break. Especially when you do the wild changing of stuff like I'm doing, where I just change all these things willy-nilly. Okay, so it doesn't see the green car at all. It's not going to see this black car, but it'll probably see the silver one behind it. There it is. Cool. Scale factor. We were running at 1.1 before, so let's see what happens when we run at 1.1 here. And we can just change a lot of these and let's see what this one comes up with. We're a little bit over the hour, but I just kind of wanted to play around with it just a little bit more. Now we're seeing the green car by changing the scaling. We're seeing the green car, we're seeing the black car, and the white one going by. So that scale factor did seem to help. However, I'm seeing a couple more false positives in here. but it seems to be picking up vehicles better. Even our one that's turning around. I don't know why it's not drawing a good box around it, but interesting. So it's getting better. I like it when things are getting better, when this is our computer vision here is improving. There's a woman walking by. Let's see if it picks up anything off of her, which it should not. Yeah, it should just be focused on vehicles. Oh, it's picking up her legs again. And we look over here, this is our pre-processing image. And our pre-processing image could probably use a little work, like the brightness can go back down. And I bet you this will help. Let's find out. Thank you, CCNet, new follower that came in, and Daniel Shad, another follower. Thank you for coming in and joining my stream. It's pretty fun. We do this every week. We do a new computer vision thing. We might do some face detection soon. And so I changed the brightness, and now we're picking up that stupid manhole cover again. But we're doing pretty good as far as picking up vehicles with this particular algorithm. Now let's try our hard one. We have a hard one. Let's go back to that one. This one is the one that's at all kinds of different angles and has a ton of different noise, which is why I chose it. Because I knew as soon as the first time I saw this live stream, I knew it would be hard to get vehicles out of it. And look, we're even getting, we're getting pretty good vehicles out of this. The frame rate, I don't know why it's doing that, but let's see if there's a way to set the frame rate for this. And we are using, remember the name of OpenCV false. CV2 video capture. Set frame rate. Video capture. Reduce the frames. And see if there is there's got to be a way to do this. Oh, looks like VL42. There we go. We can set our frames per second in our capture. Cap set. Frames per second. 20. Let's see if that helps a little bit here. Nope. Cap before assignment. I had it right the first time. I don't know why I tried to put it before here. And that doesn't seem to affect the frames per second on there. So maybe I just need to do some hand timing of this. I will look into that before our next Power Hour. I will look into how to limit the frame rate because the incoming frame rate is not as fast as it is on here. I mean, this is slower than it was before, but it's still too fast. And as we can see on this one, it's a little bit more accurate, which is cool. It's cool. I like that. So we're getting there. We're getting closer. I think by next week, we will have this even better, and we can start counting these things. So I want to count these cars. Now, one of the problems that we're having here is you can see these squares keep changing size and they keep blinking. So every time they do that, if we try to count the cars now, there's going to be like 10,000 cars because it just keeps blinking and starting up and blinking and starting up. And yeah, it's not working so great. But we will get this. This is closer than it was when we started today. But it's still not quite the way I would want it to be. So we're getting close. Thank you, everybody, for watching. Thank you, folks, for following. Now, I'm going to find someone cool to raid, and we're going to raid their channel. And it's going to be awesome. If you have a suggestion for somebody in the chat, drop it in the chat. We're going to do that. YouTube folks will not be seeing this, but yeah. Clark IO. Planning a PC build. Oops, I need to mute this. See what Coding Guarding is doing here. Svelte kit. Jackie codes. Game dev. Yeah, I'm trying to find something that I think would be interesting for the folks watching right now. So if this person accepts raids, this looks super interesting. This looks more interesting than what I was doing here, so this could be cool. Thank you very much for coming, and I will see you next week on the Computer Vision Power Hour. It's going to be fun. It's going to be great, hopefully. Let's roll.